Welcome to Creata classes. In this lecture, we will do the incircles. Till now, we have done the basic introduction to the angle bisectors. Let's start with the lecture. Let's take a random triangle ABC. This is the triangle ABC. Let's draw the angle bisector from the vertex A, B and C. These are the three angle bisectors. We have limited these angle bisectors only up to the incenter. I is the incenter, that is the intersection point of the three angle bisectors. We have not extended the angle bisector to the sides. In actual, these angle bisectors will touch the three sides of the triangle. But for this case, we have limited the angle bisector to the incenter only. Okay, that is the point I. So we got the three angle bisectors as AI, BI and CI. Let's draw the perpendicular from the incenter to the three sides of the triangle. ID, IE and IF are the three perpendiculars to the side BC, AC and AB respectively. Are you able to visualize many triangles in this figure? These are the 6 small triangles that are formed in this whole triangle ABC. If we take these two triangles, that is triangle FBI and the triangle DBI, are you able to observe these two triangles are the congruent triangles? Let's see how these triangles are congruent triangle. First of all, both of these triangles are a right angle triangle, that is angle F and angle D are right angle. Further, BI is the angle bisector of angle B, that is both of these angles will be equal to each other. If two angles of a triangle are equal, so we can say angle FIB and angle DIB will be equal to each other. Both of these angles will be equal to each other because rest two angles of the triangle are equal. Okay, any issue? Further, BI is equal to BI, that is the common side. BI is the angle bisector of angle B. So can we say angle FBI is equal to angle DBI? Both of these angles will be equal to each other. And just now we have seen angle FIB is equal to angle DIB. So by ASA, that is angle side angle rule, we can say both of these triangles are congruent to each other. Got it? So by CPCT, we can say that corresponding sides will be equal to each other. That is FI will be equal to DI. Basically FI is equal to DI. This is the result of angle bisector equidistance theorem. That is a part of the basic geometry. As per the angle bisector equidistance theorem, that is the additional to this chapter. I am just adding a small concept. As per angle bisector equidistance theorem, any point that is on the angle bisector is equidistant from the two sides of the angle. It means that if BI is the angle bisector of angle B, AB and AC are the two sides and BI is the angle bisector of angle B. If we take any point on this angle bisector, say point I, then this point will be equidistant from these two sides. And we have covered that the distance between point and the line segment is the shortest distance, and the shortest distance is the perpendicular distance. So in other words, we can say the perpendicular distance between the point and the line segment for both of these sides will be equal to each other. That is IF is equal to ID. This is angle bisector equidistance theorem. That is, if we take any points on this line segment, these points will be equidistant from both of these sides. That is, this distance will be equal to each other. And the proof of this theorem is that by proving both of these triangles are congruent to each other. That is, we have done. So you can use either way. Either you can say IF is equal to ID, that is by the angle bisector equidistance theorem, or you can use the congruency of the triangle to prove IF is equal to ID. I have just added this small concept in between our main topic. This is the part of the basic geometry. Moving further, if we take these two triangles, that is triangle AIF and triangle AIE, here also can we say both of these triangles are congruent to each other? We have used the same philosophy. So we got FI is equal to EI. Similarly, if we take these two triangles, that is triangle CEI and triangle CDI, we got EI is equal to DI. So by comparing all these three equations, we got Fi is equal to Di is equal to Ei. That is, these three line segments will be equal to each other, or the perpendicular from the incenter to the three sides are equal to each other. So if we are having any triangle with the incenter as I, so for that triangle we can say the perpendicular distance to the three sides from the incenter is equal to each other. We can also say the point I, that is incenter, is equidistant from the point F, D and E. The point I is at the same distance from the 3 point F, D and E. Are you able to catch that these wordings are matching with the wordings of the fundamentals of the circle? That is, the center of the circle is at equidistance from all the points on the circumference of the circle. So can we draw a circle with center as I, that is incenter, and the radius as IE, IF and ID? Okay, got it. This circle is known as incircle, and IE, ID and IF are known as the inradius. Incircles and inradius. Incircles touches the three sides of the triangle and it is inside the circle. This is very important concept. So we have covered incircle, inradius and incenter. Further, are you able to compare this with the fundamental of the tangent? Here AB, AC and BC are the three tangents to the circle. We know tangents are the lines which touches the circle at only and only one point. And we also know that tangent and the radius make the angle of 90 degree. Okay, here these three angles are 90 degree. So can we say AB, AC and BC are the tangents to this incircle? This is also the property of the incircle. So if we got a question that is to draw the incircle inside the triangle, how we will proceed? We will take the triangle. Firstly, we will draw the three angle bisectors of the three angles of the triangle. The point of intersection of three angle bisectors will be incenter. That is the center point of the incircle. Then we will draw the three perpendiculars from the incenters to the three sides of the triangle. That will be the radius of the incircle. Now with the help of compass, we will take the center as I and the radius as IE or ID or IF. We can draw the incircle. This is the procedure to draw the incircle. Got it? So we have done with incircles, inradius and incenter. Now we will move to the next fundamentals. Here in this fundamental, we will see the formula of the radius of incircle, that is inradius. We will see the formula of inradius. Let's see. So we will take the same figure, that is triangle ABC, with angle bisectors as AI, BI and CI. Here IE, IF and ID are the inradius for this incircle. We will denote this inradius as small r. IE, IF and ID is equal to small r. For simplicity, let's denote BC as A, AC as B and AB as C. We have just denoted the three sides of the triangle with the letter A, B and C. If we take the triangle BIC, okay, this is the triangle BIC, can we calculate the area of this triangle? Let's do so. We know the area of the triangle is equal to half into base into height. Here base for this triangle is BC and the height of the triangle is ID. And ID is equal to R and BC is equal to A. So we got the area of the triangle BIC is equal to half into A into R. Okay, got it? Similarly, the area of the triangle AIC will be equal to half into base into height. Here B is the base and R is the height. So we got area of triangle AIC is equal to half into B into R. Similarly, can we say the area of the triangle AIB is equal to half into C into R? Okay, we have got area of these three triangles. If we add area of these three triangles, are you able to observe area of these three triangles is equal to area of this complete triangle ABC? Let's add all the three equations. We got area of triangle ABC is equal to half into R into A plus B plus C. If you observe here, A plus B plus C is the sum of the three sides of the triangle ABC. And we know the sum of the three sides of the triangle is the perimeter of the triangle. Perimeter is the total length of the boundary of the figure. So for this triangle ABC, the perimeter will be A plus B plus C. So can we replace A plus B plus C with the perimeter? So we got area of the triangle ABC is equal to R by 2 times the perimeter of the triangle ABC. Can we replace the perimeter upon 2 as semi-perimeter? Okay, semi-perimeter is the half of the perimeter. So we got area of triangle ABC is equal to R times the semi-perimeter. On solving, we got the formula of the radius of the incircle, that is in radius is equal to area of the triangle ABC upon semi-perimeter of the triangle ABC. This is the formula of in radius. We can denote area of triangle with delta symbol and semi-perimeter with capital S symbol. Okay, got it? This is very important formula, will be used many times in solving the question related to incircle and the in radius. So moving further, let's apply this formula to a right angle triangle. You can say this is a small question or a special type of case. We are applying the formula of the in radius into a right angle triangle. For that, let's take a right angle triangle with the three sides as A, B and C. There is an incircle which is touching the three sides of the triangle and R is the in radius. Let's apply our formula, that is in radius is equal to area of the triangle upon semi-perimeter. For this right angle triangle, the area will be half into base into height. Here A is the base and B is the height for this triangle. So we can say area of triangle is half into A into B. And we know semi-perimeter of the triangle is A plus B plus C upon 2. Let's put the area and semi-perimeter into the formula. On solving, we got radius, that is in radius is equal to AB upon A plus B plus C. Let's keep this separately. And moving further, let's apply the Pythagoras theorem to this right angle triangle. We got A square plus B square is equal to C square. And we know the formula of A plus B whole square is equal to A square plus B square plus 2AB. And just now through the Pythagoras we have seen A square plus B square is equal to C square. Let's replace A square plus B square with C square. We got A plus B whole square is equal to C square plus 2AB. Let's calculate the value of AB from this equation. We got AB is equal to A plus B whole square minus C square upon 2. We have calculated the value of AB so that we can put this value into the equation that we have got for the in radius. Let's put the value of AB in our equation of the in radius. We got R is equal to A plus B whole square minus C square upon 2 times A plus B plus C. On applying simple algebra and simple mathematics, we got in radius, that is R, is equal to A plus B minus C upon 2. Okay, this is the formula of in radius for a right angle triangle, that is A plus B minus C upon 2. That is the sum of two legs of the triangle minus hypotenuse upon 2. This is a special case of in radius in a right angle triangle. We have just solved this question because this type of questions are generally asked in the competitive exam. So if you directly know the formula of in radius in a right angle triangle, you can directly apply in the competitive exam and save the time. Just a special case of a incircle. Let's move to the next fundamental. For this fundamental, let's take a triangle ABC with three angle bisectors meeting at the point I, that is the incenter. I will keep on repeating the fundamental, that is what is incenter, what is incircle, what is in radius, so that by repeating to the fundamental you will memorize it. So it is like a working revision. So moving to this concept, here ABC is a triangle and AI, BI and CI are the three angle bisectors. As per this concept, angle BIC means this angle is equal to 90 degree plus half of angle A. This is very important relations, and generally MCQs type of questions are asked from this fundamental. Let's see the proof. The proof is very simple and very easy. You can pause the video and try in your notebook. Okay, simple fundamentals of triangles are applied. Now back to the proof. We know the sum of three angles of a triangle is 180 degree, that is angle A plus angle B plus angle C is equal to 180 degree. Let's divide both sides of the equation by 2. We got angle A by 2 plus angle B by 2 plus angle C by 2 is equal to 90 degree. Moving further, let's check the triangle BIC. Okay, we have taken the triangle BIC because we have to calculate the value of angle BIC. For this triangle, this angle is equal to half of angle B. Why? Because BI is the angle bisector, and angle bisector divide the angle into two equal portions. So this angle is angle B by 2 and this angle is angle C by 2. Again, applying the property of the triangle, that is sum of three angles of the triangle is 180 degree. We got angle B by 2 plus angle C by 2 plus angle BIC is equal to 180 degree. Let's replace the value of angle B by 2 plus angle C by 2 from our first equation. That is angle B by 2 plus angle C by 2 is equal to 90 degree minus angle A by 2. We have used the first equation. On solving, we got angle BIC is equal to 90 degree plus half of angle A. That is our formula. Angle BIC is equal to 90 degree plus half of angle A. Okay, we have done this formula. Based on this formula, let's take a small question. The question is, refer the figure. I is the incenter of triangle ABC. Find the angle BIC. In the question, I is given as incenter and we have to find the value of angle BIC. Angle DAC is given as 110 degree. If we observe BD is a straight line, so can we say angle BAC plus angle CAD is equal to 180 degree? Okay, linear pair axiom. Sum of angles on a straight line is 180 degree. So on solving, we got angle BAC is equal to 70 degree. We got angle BAC as 70 degree. Now let's apply our formula of incenter. That is angle BIC is equal to 90 degree plus half of angle A. And just now we have calculated angle A as 70 degree. On solving, we got value of angle BIC is equal to 125 degree. That is the answer of the question. Very simple question, just we have taken to show the implementation of the formula. So we have done with the incircles. In the next lecture, we will do the external bisector angle and the excenter. Okay. Thank you very much for being with Creata classes. Bye for now.